Hello, this is Mrs. Kohler, and this podcast is naming binary ionic compounds. Now, that sounds kind of intimidating, but one thing you want to remember is that the word bi means two. So we are just naming ionic compounds that contain only two elements. Take a moment now to make a note of what bi means on your paper, and also write down the essential question. So the first question is, when do ionic compounds form? You know with covalent they formed when both elements were nonmetals. Ionic compounds form when you have a positive ion and a negative ion and they become attracted to each other. Last unit we talked about ions. We talked about cations, which are positive ions, and anions, which are negative ions. So cation, anion. Most of the time, cations are metals, and most of the time, anions are nonmetals. So here's a portion of the periodic table. I know you already did this last unit, but make sure that you have these charges filled in, that the +1, +2, +3, -3, -2, -1. The plus and minus 4 isn't as big of a deal because I'm going to try not to use those very often. But you do need to know that they can form either positive or negative. And this should in the middle of the periodic table that doesn't have charges above it, you're going to ignore that for now. We're actually going to talk about that in the next podcast. For this podcast, we're only going to work with the columns that have charges above them. So there are three basic rules for writing and naming binary ionic compounds. First rule is that you're going to write the name of the metal. That's the one that's going to have the positive charge. And you don't have to do anything with that. You just write the name of the element. You're going to then write the negative ion, which is usually nonmetal, but you're changing the end to IDE. Now take note with both of these, there is no prefix involved at all. When you have a metal and a nonmetal, you're not using prefixes. And when you do need to find the formula using a name, you need to make sure that the charges add up to 0. What we're going to do now is we're going to move on to some examples, and for that we'll be switching to a pencast. Okay, welcome to Naming Binary Ionic Compounds. We're going to do the examples right now. So the first example we're going to start with is Na plus and Cl minus. Now remember the exceptions I gave you. Na is sodium and Cl is chlorine, so we're actually composing sodium chloride. Now the first thing we need to do is we need to make a formula for this so that the charges add up to 0. So Na plus, when there is no number written there, it actually means +1. And chlorine, when there's just a charge and no number there, it actually means -1. So if we have Na with a charge of +1 and Cl with a charge of -1, all we need to make it to add up to 0 is one of each. So your formula is going to be NaCl. You used 1 sodium, 1 chlorine. Write that on your paper. Now for the name, look up at the rules. The first rule is to write the positive ion, which is sodium. And you don't do anything to the name, you just write it, which is sodium is the name of the metal. Now for the second one, we have to change the ending to IDE. So chlorine becomes chloride. So that INE becomes IDE. So that's sodium chloride, NaCl. You should write both of these things on your line. Now for the second one, we have magnesium and fluorine. So magnesium has a charge of 2+ and fluorine has a charge of -1. So in order to make these add up to 0, we have a +2 and we have a -1. If you add that up, you still get -1. So you need a charge that adds up to 0. Well, the way you do that is to have 2 minus 1s. So plus 2 minus 1, that's going to equal 0, which means that you're going to need 2 of these fluorines to make your formula. So you need Mg, and no number after it means 1, but you need 2 Fs. So your formula is MgF2. And for the name, Mg is magnesium, and F is fluorine, which becomes fluoride. Now there is a big difference here. When we were doing covalent, we were putting prefixes at the beginning, but for ionic, there's no prefix. So make sure that you know when you're looking at a compound whether you're dealing with ionic or covalent. Now for this next one, Al3 plus and O2 minus, that's a little more complicated to figure out. If we have one positive 3 and one negative 2, that's not adding up. So let's try putting in another negative 2, and then you get negative 4 and plus 3, which still doesn't add up. So you need another plus 3, another minus 2, and finally it adds up because here you have plus 6 and here you have minus 6. So you had to do 2 of the aluminums and 3 of the oxygens. So your formula becomes Al2O3 because you needed 3 of this and 2 of this. Now, if you noticed from this example and the last example, there was kind of a pattern there. What you need to do is you just need to take the 2 numbers up at the top and you need to cross them over each other. So the 3 goes behind the oxygen and the 2 goes behind the aluminum. But you don't carry the charges, you just carry the numbers. So the name is, Al is aluminum, aluminum oxide, and that's its name. Now the next 3 give you the name and you have to figure out the formula. So for lithium sulfide, lithium, its symbol is Li, and you go to your periodic table and its charge is +1, so it gets a plus. Sulfide, that's sulfur, and that gets a charge of -2. So in order to balance out the charges, you need 2 plus 1s to balance out that 1 minus 2. So your formula is Li2S. And this would be a 1, but nothing goes there because it's just understood to be 1. So once again, if you had just brought the 2 over here and the 1 over here, you get the same formula. Aluminum fluoride. Aluminum is in your +3 column. Fluorine is in your minus column. So if you bring your 1 down here and your 3 over here, you get AlF3. And then calcium oxide, this one's a little bit special. You get calcium is Ca, and its charge is 2+. Oxide is oxygen, its charge is 2-. Now, if you were to bring down the numbers from each of these, you would end up with Ca2O2. If you have this happen with ionic, what you need to do is you need to reduce this. And you need to change this. You need to divide each one by 2 so that your final answer is CaO, because you have to reduce it as if it's a fraction. So that's your final answer. Now what you should do, since you've watched this podcast, is you should go to pages 9 and 10 and practice naming binary ionic compounds. Have a great day.